Hi guys, welcome back. So today, we're going to be talking about the binomial theorem. What's that, you ask? Well, follow me.
In the mid-17th century, a French mathematician by the name of Blaise Pascal created the one and only Pascal's triangle. Well, it wasn't the only one. In the 13th century, a Chinese mathematician by the name of Yang Hui created the Yang Hui triangle, which is the same thing, just basically in a different language. Now we know Pascal's triangle, but what does it all mean? The first thing we need to understand is factorial. For example, on factorials, let's use the number 6. So the sign for a factorial is an exclamation point, and know that does not mean that the number is excited. So what a factorial is it multiplies the number given by all the numbers that came before it except 0. So in this case, it would be 6 times 5 times 4 times 3 times 2 times 1. And that all comes out to 720. Well, with what we will be doing next, let's try dividing factorials. So say we have 9 factorial divided by 7 factorial. Now, this might seem like it's the harder way to go about this, but in all reality, this will be the easiest way because we will be simplifying. So, you want to write 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, all divided by 7 times 6 times 5 times 4 times 3 times 2 times 1. And if you're comfortable with factorials, you would have automatically gone 9 times 8 times 7 factorial, all divided by 7 factorial. It's the same way, this might be a little easier for you to write. So over here, you would just cancel out this and this. Same thing over here, just cancel them out. Both of them actually come out to equal 9 times 8, which is 72. Pascal's triangle is basically all the answers to what we're about to learn now. But before we know why, we have to know so. Now that we know all about dividing factorials and what factorials actually are, we can use this equation. You don't really need to know what C is for now, so let's just practice working with the equation. Just for a little heads up, K has to be greater than 0, and N has to be greater than K. So let's just plug into numbers and let's try this out. Let's do N is equal to 5 and K is equal to 3. So this is going to look like C of 5 comma 3 is equal to 5 factorial divided by 3 factorial times 5 minus 3 factorial. Yes, that's all divided. Which comes out to be 5 factorial divided by 3 factorial times 2 factorial. And if you remember what we did before, we can do this. 5 times 4 times 3 factorial, just because that's the biggest one on the bottom. And that's times 3 factorial times 2 factorial. So we can cancel these two out. So that's equal to 5 times 4 over 2 times 1, which is equal to 20 over 2, which is equal to 10. Now, if we look at our Pascal's triangle over here, and we go to row 5, and then we go to column 3. Well, they're kind of like almost. We'll go 3 in, and we don't count the ones. So we go to 5, and we go 1, 2, 3, and it happens to be what we got here. Wow! Pattern of our Pascal's triangle right here, and that is that the outskirts of the triangle are actually 1. Now, this is because C of n comma 0 is always going to equal 1, and this will be the zeros. And that is because 0 factorial is equal to 1. And that goes the same with C of n comma n factorial. And that is all 1, because, you know, something divided by something itself is going to be 1. Now that we have this, I think that we should learn how to do the... If you look at the name binomial, bi means 2, and nomial means number. So, this might seem easy, but I want you to bear with me. So, let's do a plus b to the first power. That is obviously going to equal a plus b. Now, what if it was a plus b in parentheses all squared? Wouldn't that just equal a squared plus b squared? Well, you're wrong. It's going to actually equal a squared plus b all squared. That is all going to equal a squared plus 2ab plus b squared. Now, this is because of the whole FOIL thing, or whatever you kids call it these days, because a plus b times a plus b. Do that whole thing, and you get that right there. To find a number that was just like a plus b all squared. Well, there's actually a formula for this. Check it out. So let's use u and v. U plus v all squared is going to equal 1 u squared plus 2 times u times v plus 1 v squared. So let's try a bigger exponent than 2. Let's say 4. So u plus v fourth is 1 u to the fourth plus 4u to the third times v. This is a little different. Plus 6u squared v squared plus 4u v cubed plus 1v to the fourth.
Those leading coefficients do look quite familiar. That's because they're all from Pascal. Since the last equation we just did was to the fourth power, we're going to go down to Pascal's triangle fourth row. And this is going to be 1, 4, 6, 4, 1. Sounds familiar, right? Well, now that we know how to find that, let's learn how to find the exponents for u and v within the equation. For u, you're going to start at 4 and count all the way down to 0 as you go down the equation. For v, you're going to do the opposite and start at 0 and go all the way up to 4 until you end the equation. Basically, all the exponents should add up to the original. For example, u to the third times v to the first would be 3 plus 1 is 4. Let's try this out with,
Let's try 7 plus 5 to the third. So, this would be 1 times 7 to the third plus 3 times 7 squared times 5 plus 3 times 7 times 5 squared plus 1 times 5 cubed.
You might have been wondering how I got the formula for the equations I had just did. That is this one right here. So this all seems pretty straightforward, except for this part right here. Well, this is what we did in the beginning, and that is right here, which is also on the Pascal's triangle. So if you don't have one handy on you all the time, this is the equation you would use. So let's try this out with some numbers. Let's do a minus 2bc to the fifth.
Did I say numbers? Because I meant numbers and variables to make it a little trickier.
Okay, so this would be a to the fifth plus c to the 5, comma 1 times a to the fourth times negative 2bc to the first plus c to the 5, comma 2 times a to the third times negative 2bc to the second. Sorry, that should be out there. Plus c to the 5, comma 3 times a to the second times negative 2bc to the third plus c to the 5, comma 4 times a to the first times negative 2bc to the fourth. Sorry, I ran out of room there. And that is plus
Negative 2bc to the fifth.
So now that is a lot, and we need to simplify that out.
But first we need to figure out what these things are right here.
What I'm going to do,
I'm just going to look at Pascal's triangle, but if you didn't have this on you, that's the equation you would use. So, let's do it. So this is going to be equal to, first off, we're using this word. Oh,
maybe I should just underline this.
okay. So, first will be 1. So that's 1a to the fifth, which we already knew that. Okay. Plus 5. So that's going to be 5 times
a to the fourth times
negative 2bc to the first. That's going to be plus 10 is next.
So we're doing 10
Plus 10 to the a to the third. Negative 2bc to the second. Oops, sorry. Plus 10 times a to the second times negative 2bc to the third. Plus 5
times a times negative 2bc
to the fourth. Because that was 5 right there. So now
it's just going to be 1 again. 1 times negative
2bc to the fifth. Just to make a little room,
I'm going to erase this top part to make sure we can do the next part. Let's do algebra to make sure this is all simplified into the simplest form. So this is going to be equal to a to the fifth, and then once we do 5 times negative 2 and then do all the variables out, it's going to be minus 10a4bc, but we don't really need the ones there, but just to make sure everyone's clear. And then that's going to be plus 40 because negative 2 squared is 4, positive 4, and then times 10 is 40. So it's going to be 40a, 3, b, 2, c, 2. And then next is going to be a minus, because this is going to be negative, because negative 2 cubed is 8, negative 8. That times 10 is 80, so that's going to be 80a squared, b cubed, c cubed. Now, negative 2 to the fourth is positive 16, and then positive 16 times 5 is going to be 80. So this is plus 80a, b4, c4, and then The next one is going to be negative because it's an odd exponent times a negative number. So this is going to be minus 32b5c5 because negative 2 to the 5th is negative 32. And if we forgot what the original one was, that is what a minus 2bc to the 5th is equal. That was a lot of work, but everything we worked with today is finally piecing itself together. Since we got that down, let's try a range. We're going to be doing x squared times 1 plus the square root of 3, and that right there is all going to be to the 4th power. So let's just start doing it out in our simplest form. So 1 to the 4th plus to be c times 4 comma 1 times 1 to the 3rd times square root of 3. Sorry, I had to think about that. Now that's going to be c of 4 comma 2 times 1 squared, which is going to be 1, but we'll just write it for there for now, times square root of 3 squared. And then that's going to be plus c times, or c of 4 comma 3 times 1 to the 1st power. And then that's going to be times square root of 3 cubed. Next is going to be plus square root of 3 to the 4th. Now what we're going to do is we're going to create these and we're going to use this. So we're going to be using the 4th row right here. So first is just going to be 1 again. So 1 to the 4th plus c41, that is going to be 4. So 4 times 1 cubed times square root of 3. Then it's going to be plus, next in line comes 6. So it's going to be plus 6 times this one right here. 6 times 1 squared times square root of 3 squared. The next is going to be 4 again. So that means it's going to be 4 times just 1 times square root of 3 cubed. The next is going to be 1 again. So that's 1 times square root of 3 to the 4th. So now we're just going to take all that there and simplify it down using algebra. So if we do this out, that's just going to be 1 plus, then square root of 3 times 4 is just going to be 4 to the square root of 3 plus, so square root of 3 squared is obviously 3, so 3 times 6 is 18, plus square root of 3 cubed is just 3 times the square root of 3, so then that is times 4, so 12 to the square root of 3, and then that plus square root of 3 to the 4th is just plus 9. So that here gives us 1 plus 18 plus 9, which is 28, plus 4 to the square root of 3 plus 12 to the square root of 3 is going to be 16 square root 3. Now don't forget, we have to multiply this out by x squared. That's going to be 28 x squared plus 16 to the square root of 3 x squared. You might be wondering when or why in the real world you would ever use binomial expansion. Well, I'm about to list 5 major ones for you. Number 1, IP address distributing. In computing, this is really needed, and I'm not really good with computers, but I do know. Number 2, economic predictions. When predicting the future for the US economy, the binomial theorem really comes. Number 3, architecture. From calculating the magnitudes to the cost and time for the projects done by the architects, the binomial theorem really is the way to go. Number 4, weather forecasting. Meteorologists have to predict the crazy stuff our weather does and what will be like in our future, and this is made possible by the one and only. 5, math. Mathematicians and math teachers use this quite a bit. Well, if you're a math teacher, you use it about annually for about a week at a time. Talking a lot about the algebraic applications for the binomial theorem. So I think we should give it a shot with geometry, because why not? That's the last piece of math for today. But what we're going to be doing is finding the increase of volume when we increase the radius of a sphere by 0.001. Sorry. So we're just going to start off by making it like this. V times r plus 0.001 minus VR equals, since we know this is the volume of a sphere, 4 thirds pi times r plus 0.001 cubed, that's minus 4 thirds pi r cubed. So we've been doing this whole entire video on binomial expansion, so we know how to do this right here. So we go over here to row 3, we're going to be using 1, 3, 3, 1. Okay, cool. Now, this is going to be equal to 4 thirds pi times r cubed plus 3 r cubed plus 0.001. I'm sorry, that's times 0.001 plus 3r times 0.001 cubed, sorry again, squared, plus 0.001 cubed, then that's minus 4/3 pi r cubed. Now, we're going to simplify this part out, and we get equal to 4/3 pi r cubed, because, just doing that out right there. So now we're going to move over to here. So that's divided by 3 times 4. Since the 3's there, the 3's cancel out. So it is going to be plus 0.004 pi r squared. And that is plus 3.0000. Now I'm going to to my row. Okay, so we're going to simplify that up. So we get 4/3 pi r cubed plus, so we do this out here, remember the 3 and the 3 cancel out, so it's just going to be that times 4. So it's going to be 0.004 pi r squared plus, and then the same thing over here, the 3 is going to cancel out, but we're still multiplying that by 4. So it's going to be 0.12345 zeros and then 4 pi r plus, I'm going to move all the way down over here because there's not enough room for 8 zeros after the decimal point. So 0.123456784 4 pi, all divided by 3 because that one did not have to have a 3 in front of it. So we do actually have to divide it by 3. And that's all minus 4/3 pi r cubed. Now if we simplify that out even more, you get 0.004 pi r squared plus 0.1234504 pi r plus 0.0000004 divided by 3, that's a pi. It's supposed to be right there. So there we go. There we have it.
To debrief, we kicked it off with some Pascal's triangle history and factorials, which were essentially the easy part. Ensuite, nous avons introduit la question. Next, we introduced the equation c of n comma k is equal to n factorial divided by k factorial times n minus k factorial, which is a mouthful, which tied into even more of a mouthful equation that I'm not saying and just going to be typing here if I know how to. Sample problems, which, if you ask me, were greater than equal to 4 short problems, greater than equal to 2 long problems, and expertly completed and narrated. Then came in the real-world applications, geometry, and me talking to you right now. Well, anyways, that's all folks for the binomial theorem. Thank you and, literally, good night.